Hi everyone, my name is Yuan. I'm a research scientist at MIT Spoken Language System Group working on audio and speech AI. Today I'm going to talk about two things, audio perception and audio understanding. First, I will introduce two of our recent research on extending audio perception abilities. And second, I will dive deep into how we build the world's first audio large language models that not only can perceive sound, but also understand sound. So let's get started. We have over 100 years to make a machine recognize sounds, starting from a toy called Radio Rex about 100 years ago, all the way to OpenAI's Whisper model that can recognize about 100 languages. One problem of this line of research is they only focus on speech, but speech is only a small portion of sounds. There are many important sounds like sounds of animals, sounds of tools, sounds of the environment that are equally important to embodied AI systems. And the first work we did is to extend speech recognition to general audio recognition. We built a model that can simultaneously recognize speech and non-speech audio. This is a demo. You can see the non-speech audio text in yellow and the speech spoken text in green.
Just nice and hot, about medium high. And I love that sizzle. The rest of the onions and the rest of the garlic. Okay, the onions are browned a little bit. It's been maybe not even 2 minutes. Now it's time to add the ground beef. And I got a half a pound.
You get a point? And another direction we are working on and led by a PhD student in our lab, Andrew Rodchenko, is to combine the visual and audio modalities. So the idea is in a very noisy environment, it's hard to recognize speech purely based on audio. But if we allow the machine to do lip reading and combine it with audio, it can greatly enhance the performance. And here is a demo.
The ship is not usually not based on a zero situations where you call right on a two nice. The ship is not usually not based on a zero situations where you right on a two nice.
It's using past experience based on similar situations to try to make meaning. It's using past experience based on similar situations to try to make meaning.
Under the hood, this model combines two models, one visual model and one audio model, and do a joint decoding. So as you see in these two demos, machine audio perception models is already very close to or already surpass human ability to recognize audio and speech. But there is still one major difference between human and machine intelligence. That is understanding. What do I mean by that? Think of this. If you hear a sound of a cat, you know that it's a cute animal and probably asking for some food. In contrast, if you hear a sound of tiger, it's probably also asking for some food, but in another way. So although we cannot clearly distinguish the sound of a tiger with the sound of lion or other wild animals, we immediately feel danger and we decide to run from the spot. And of course, we can understand speech. So my point is, we humans are not only a classifier, we can understand the implicit meaning of the sound, and that connects to our emotions and actions. In contrast, modern automatic audio perception models, internally, it only maps audio into a set of indices. And we use a label set to map it back to classes. So it's just a classifier. It does not associate with these sounds with actual concept and do not know what these sounds means. So our goal is to build a new AI model that not only can do audio perception, but can also understand what the sound means, just like us. One important observation here is a large language model trained on poor text. Although it's only trained on text data, it's trained on a lot of audio-related text data, meaning that it already encodes a lot of information, knowledge, reasoning about sound. For example, if we ask what is the acoustic feature of dog barking, ChatGPT can give us very detailed answer. I think it's better than me. So we have two types of models. We have conventional audio models have strong perception ability but do not understand. We have text-based large language models that understand sounds, has reasoning ability, but they cannot perceive sound. So natural idea is to combine them together and we build our first large language model called Listen, Think, and Understand. Internally, we not only feed the spoken text to the model, but also feed a set of continuous acoustic features to the model. Because these features encode rich information about acoustic features, about non-speech audio events, about the speech paralinguistics, about speaker stats, like the emotion, like the identity, like the gender. And because these features cannot natively understand by the large language models, we have to train the model, and we collect a new data set contains about 10 million audio samples to train our model. And let's come back to the cooking demo. Since it's a language model, we can now ask any question to the model using natural language. We can ask what is gender of the speaker. The model can tell us it's female. And the interesting thing is it also tells why it thinks it's a female. We can also ask it to describe the acoustic feature in natural language. And we can ask what do you feel? And the model tells us it invokes hunger by listening to this audio. And let's see another demo about non-speech audio.
But now used to coordination.
You hear a siren of an emergency vehicle before you're seeing that in the video. That's a very important information. If we import the audio track of this video to the model, and we can ask the model what is the weather. The model can tell us it's a raining day, and we can ask the model where could this audio be recorded. The model can tell us in a busy urban area. And the model can even tell us that we need to move to the side of the road and stay there until the emergency vehicle passes. So we can imagine this kind of understanding ability is crucial for embodied AI systems like autonomous vehicles. And we make this a public demo. If you scan the QR code, you can upload your own audio or record yourself and ask any question to the model to play with the model. Okay, so to summarize, we built a new model that simultaneously perceives sound and understands sound. But the new understanding capability raises some new questions. So, for example, how can we enhance and evaluate the understanding ability? Can the machine understand sarcasm? For example, if we say the weather is so good today in a raining day, can the model understand that what I actually mean is that the weather is pretty bad? How can we enhance the reliability of this understanding ability? How to control it not overinterpret or underinterpret the sound? And fundamentally, how can we evaluate? How can we measure the understanding ability of the model? We cannot measure it by accuracy. We have to hire some human. Can we do it automatically? These are all new questions. And the second question is, how can we apply these models? Can we apply this to personal assistants like Siri or Alexa? Can we use this for customer service? And can we apply this to autonomous embodied AI systems like autonomous vehicle? And in the future, we will integrate this model with audio generation model to make the audio in, audio out end-to-end model. And we will combine it with a visual model to make it audio-visual understanding model. So I want to thank my collaborators, the PhD and postdocs in our MIT Spoken Language System group, as well as the senior advisors, Leonard and Jim Glass. This concludes my talk. Thank you so much.